So the second page of this homework has more worded, complicated questions, but they're not actually that complicated. What we've got here are two compound solids, so let's think about the compound solid we've got. This is made of two cones. We're going to assume that those two cones are identical because it doesn't tell us anything different, and if they're not identical we can't work it out. So, actually we can, so right, so this is two cones. Let's think about it as cone 1 and cone 2. They're exactly the same. This is 4.6 and the whole thing is 8.6, which means that half of it must be 4.3. This one must also be 4.3. Now let's just focus on one cone. So remember, a cylinder is the area of the circle times by the length. The circle is pi r squared, so that's pi times the radius squared. Is 4.6 the radius? No, it's not. The radius is going to be 2.3. 2.3 squared times by the length, 4.3. That would be the cylinder. We're not interested in the cylinder, they're cones for goodness sake. So make them into cones. How do we make them into cones? We divide them by 3. And that goes into my calculator. Pi times 2.3 squared times 4.3 equals, equals 23.8. However, I don't have one cone, I have two cones, so I have to double this. So I'm going to do 223.8 multiplied by 2, on my calculator, 47.6. Okay, now this shape here, again we're going to split it up. This one here is a cone, a short fat cone, sat on the top of a hemisphere. Okay, so let's have a look at the cone first. Imagine that the cone is a cylinder. A cylinder is a circle times the length. Circle is pi r squared. Pi times, what's the radius? Oh, hang on. Radius, what's that going to be? That's going to be from there to there. So the radius of the cone is the same as the radius of the hemisphere. But what's the radius of the hemisphere? Right, because the hemisphere goes out in all directions, the radius of a hemisphere is the same as its height. Both of those are the radius. So the radius is 3.7. The length of my cone, remember still focused on our cone, is 4.4. Oh, on the page. That would be a cylinder. We want a cone. So a cone will be pi times 3.7, the radius, squared, times 4.4, which is the height or the length, and then we divide it by 3. Pi times 3.7 squared times 4.4 divided by 3. 63.08. I'm going to need that in a minute. I'm just going to draw a box around that. Okay, so it's not my answer, that's just the cone. Now let's think about the hemisphere. Before we think about a hemisphere, before we think about a hemisphere, let's think about a whole sphere. So a sphere, as we will be told, is 4/3 pi r cubed. It's going to be 4/3 times pi times, we already know what the radius is because we worked out 3.7 cubed. But we want a hemisphere, which is going to be 4/3 times pi times 3.7 cubed divided by 2 because it's half of it. So into our calculator goes. Calculator function, fraction 4/3 times pi times 3.7 cubed divided by 2. 106.9. I'm recording, go away! Sorry. 106.09. What I do now is I add those two boxed answers together. Gives me 169.17, which rounds to 169.2. Okie dokie. Great Pyramid of Cheops is a square-based pyramid. The base has a size of 230 metres and the height is 147 metres. Using the same material, which means it would have the same volume, what would be the height if you gave the base a size of 260 metres? So first of all, let's think about the pyramid we've got. The pyramid we've got is a square-based pyramid. I don't know why I've drawn that there. Is a square-based pyramid with sides of 230 and a height of 147. So let's find the volume of my pyramid. First of all, think about it as a prism, which is the base times the height. The base is 230 times 230 and the height is 147, which gives me oh my goodness, that's lots of digits. 7,776,200 metre cubed. Okay, but I'm saying now I want a pyramid with a wider base. So I effectively want to squash my pyramid so that it's fatter at the bottom. But if I make my pyramid fatter at the bottom, obviously it's not going to be as tall. I'll show you this by drawing this one like a little bit shorter. Okay. Right, we want to find out what is the height. And we're going to do this by working, this is a prism, so the pyramid, I've forgotten a step, this is really important, I'm really glad I wrote my working out because otherwise I'm doing this all wrong for you. It's my answer divided by 3, isn't it? 200 divided by 3. 2,592,100 metre cubed. Still massive, but not quite as massive. So, anyway, we've spread out the sides of the pyramid, which means that it's going to be shorter. Now, we can work backwards because we know that the volume of a pyramid is the base area times the height divided by 3. Now, we know this is our 2 million blah blah blah, and we know this is 260 squared, okay, and we know this is 3, so we can work backwards to find our height. So first of all, I'm going to undo dividing by 3, which gives me 7,776,200, and that's going to be 260 squared times by the height. So what I need to do now is divide by 260 squared. So I take my original big number and I divide it by 260 squared. It gives me extremely long recurring decimal. Luckily, I'm only interested in one decimal place. 115.0. If you are ever asked to find a length from a volume or an area from a volume, that means we're working backwards. When that happens, write out the formula in words, think about the bits you know, and undo bits to get back to where you want it to be.